What's going on, guys? Welcome back to the channel. Today we're going to be going through the October-November 2021 Pure Mathematics 3 past paper. Okay, so this paper was a little bit more difficult, in all fairness. So it did take a little bit longer. However, we managed to pull through it. And as always, guys, if you like the video, make sure to give it a thumbs up. Make sure to comment. Subscribe, share with your friends if you haven't already, and of course turn the notification bell on as well. Without further ado, let's get right into the video, guys. Now for the first question here, this is actually a bit of a more hard question, to put as the first question in the paper, so it's worth going through. It says to solve the following equation. Right, it's an exponential equation, and I want us to give the answers correct to 3 decimal places. So the way you go about doing this is you have to recognize that, okay, with this, it's an absolute value equation. It's also an exponential equation. And so what we have to do is we're going to square both sides. And if we square both sides here, what we get is 16 5 to the x minus 1 squared is equal to 5 to the 2x. If we expand this out, we get 16 5 to the 2x minus 2 times 5 to the x plus 1 is equal to 5 to the 2x. Okay, so that's important. What have we done here? We've done the same thing. We've multiplied these together, for the middle term, and then times by 2. But remember, this can't equal like 10 to the x or something. Okay, so that's a common mistake. It's just we've done 2 times 5 to the x. Okay, let's put into that expression. And that's going to be relevant as we keep going forward. So we've got that now. Now, if we keep this going forward, what we get is 16. Okay. 5 to the 2x. Okay, minus 32. 5 to the x. Okay. Plus 16 is equal to 5 to the 2x. Now this over here, this 5 to the 2x, is the same thing as saying 1 times 5 to the 2x, no? And so if we've got 1 5 to the 2x here, we've got 16 5 to the 2x is here, what we can get from here is 15 times 5 to the 2x minus 32 5 to the x plus 16 is going to equal 0. Okay? Perfect. So we've got that bit now. Now the question becomes, how do we simplify this in a better form for ourselves? Now remember, a 5 to the 2x, right, is just like saying 5 to the x times 5 to the x, okay, because you have to add the exponents, right? So in this scenario, we're going to break it up a little bit. In fact, so what I'm actually going to do is I'm going to say this first. We can break this up into 15 5 to the 2x, okay, minus 12 times 5 to the x minus 20 5 to the x, okay, minus 32, right, plus 16 equals 0. Okay, we've got that. Now what can we do? Well, what I can say is, well, if we want to make this, if we want to chop this up a little bit, I can turn this now into 3 times 5 3 times 5 to the x, okay, times, and really you could say point here instead. You could say 15.5, because multiplication with the dot, but I'm trying to keep things as, I don't want to get confused there. So we got 3 times 5 to the x, okay, times 5 to the 5 to the x, minus 4 over here. Okay, now why is that? Well, that's the case because 3 times 5, 15. Okay, and the x's we're going to add to 5 to the 2x. Okay, you know that. And obviously 3 times minus 4, negative 12. Okay, we got that. And then moving that forward, all right, so we're going to get minus 4 here, 5 5x minus 4 is equal to 0. Okay. Choose the same thing. 4 times 5, well, negative 4 times 5, negative 20. Okay. Got the 5x here. Negative 4 times negative 4, that's plus 16. Brilliant. So we factorize this now. We have factorizers. Okay, where we've got 5 times 5x minus 4 on both sides. So we can therefore say that we're going to get 5 okay, 5 to the x minus 4. Then we got 3 times 5 to the x minus 4 equals 0. Therefore, we can say that 5x is equal to 4 over 5. Or we can say that 5x is equal to 4 over 3. Right? And then we can say this. Well, if we take the ln of both sides, okay, we get x ln 5 is going to equal ln 4 over 5. Okay, which means x is going to equal ln of 4 over 5 over ln 5. Okay, we got that. Or we can say that x can equal ln 4 over 3 over ln 5. So we get two answers here. We get two answers. We get x is going to equal negative 0.139, or x is going to equal 0.179. Okay, and these are going to be your final answers as required. Now quickly going through how exactly we did that. Okay, the key thing here, we start off by squaring both sides as you usually would. But the key thing was factorizing according to these multiples. Okay? As you can see, it's 2 times 5x. Right? We multiplied 16 out, 32, 16. Okay, and we just simplified it from there. Alright. And that allowed us to then break this down even further to get to these answers. Alright guys, now for number 2. Okay, number 2a, we've got the following question. It says, express 5 sine x minus 3 cos x in the form r sine x minus alpha, where r is bigger than 0 and alpha is between 0 and pi over 2. Okay, it wants the exact value of r and it wants alpha to 2 decimal places. So we have to recognize a few givens here. Okay, using our trig identities, we know that r x minus alpha, okay, is going to equal r sine x cos alpha minus r cos x sine alpha, which therefore means what? That means that we got r cos alpha sine x minus r sine alpha cosine x. Okay. What does that tell us? Well, if we correspond this to this, right, what does that mean? Well, what we get then is r cos alpha is equal to 5. Okay. And of course, r sine alpha is equal to 3. Okay. Now, what can we say? Well, one way to actually do this, okay, is we can square and add. If we square and add here, we get r squared cos squared alpha plus r squared sine squared alpha. Okay. That's going to give us 25 plus 9. Therefore, r squared cos squared alpha plus sine squared alpha is equal to 34. Now this is naturally just going to equal 1. So therefore r squared is equal to 34. Okay. Which means we get root 34 as a result. Okay. Now, we've got root 34 here. Alright. And we just need to find a now, alpha. So we know that r cos alpha equals 5. So we could say root 34 cos alpha is going to equal 5. Why have I said that? I've said that because obviously r is root 34, which times up by cos alpha. It plugs into this equation, right? So alpha then is going to equal r cos of 5 over root 34. Okay, and if we work that out in radians, we therefore get 0.540. Right. That's going to be the answer. Okay, so just a quick recap of that one. We just expanded this. Okay. knowing our compound angle formulas. And then we did a little trick where we squared and added. Okay, so we squared and then added, which gave us r squared cos squared alpha plus r squared sine squared alpha. That's 25 plus 9. Okay, you get r is equal to root 34. Okay, and you plug that value of r in somewhere, such as here, you get root 34 cos alpha is equal to 5, which allows you to get 0.540 radians. Alright, now for b, guys, okay, it says, hence state the greatest and least possible values of 5 sine x minus 3 cos x squared. Okay, so let's jot this down. So 5 sine x minus 3 cos x. Okay, what does that equal? Well, what that equals is root 34, okay, times sine of x minus 0.54 squared. So this now is our value. Now we need to find the max value. So max value is going to be what? Well, that's going to equal root 34 times 1 squared. Why have I said that? Why the 1? Because remember, the max value for sine of anything is 1. Okay, unless of course you got a multiplier at the start, but we don't here. Well, it's root 34. But sine itself, okay, max value is 1. And we've plugged that in. So therefore the max value is root 34 times 1 squared, which equals 34. Min value is what? Well, it's going to equal root 34 times the minimum value of this, which is a sine function, so it's going to equal 0. Okay, and therefore that's 0. And that's basically the question done. Okay, all you have to do is recognize that sine, we're working off the sine function here. Max value is 1, obviously. Min value is 0. Okay, if you times by root 34, and you know, it's squared as it wants to do, then you get the following answers. Simple as that. Alright guys, now for number 3, we got a question that actually seems relatively standard, okay? Not too complicated. So it says the curve with equation y is equal to xe to the power of 1 minus 2x has one stationary point. Okay. And it wants us to then find the coordinates of this point. So we know that obviously y is equal to xe to the 1 minus 2x. What is dy by dx going to equal? What's uv plus uv? Okay. Remember, u dash v plus uv dash. Okay. So in this case, I'm just going to let x equal u. So we've got 1 times e to the 1 minus 2x plus u, which is x, times v dash, which is going to give me x times minus 2 times e to the 1 minus 2x, which equals what? E to the 1 minus 2x. Alright, and if we take that out as a common factor, we're going to have 1 minus 2x, that's being times by, right? Okay, so we've got that. So if we set now our stationary points, let dy by dx equals 0, that means that e to the 1 minus 2x times 1 minus 2x is equal to 0, which means that 1 minus 2x equals 0, which can translate therefore into x equaling 1 over 2. Okay, so we've got x equals a half. Brilliant. We've also got y. Okay, so all we have to do now is plug that in. So y then is equal to a half. Okay, e 1 minus 2 times a half, which equals what? Half equals 0, which equals a half. Okay, so therefore the coordinates are going to be a half and a half. This one's pretty simple. Not much to really go through. Alright, now guys, for number B, it's just a case of determining whether the stationary point is a maximum or a minimum. So, we're going to say this. Right? We're going to find d squared y over dx squared, aka the second derivative. So d squared y over dx squared is going to equal d over dx, okay, of e to the power 1 minus 2x 1 minus 2x. Okay, if we apply our product rule here, we're just going to get d over dx e to the 1 minus 2x times 1 minus 2x plus e to the 1 minus 2x times d dx of 1 minus 2x. Okay. We then get what from here? Well, this is going to equal minus 2e 1 minus 2x times 1 minus 2x plus e to the 1 minus 2x times minus 2, which equals e to the 1 minus 2x 4x minus 4, right? And so we've got d squared y d squared x, plug in a point at x equals a half, okay, which is the stationary point. What we get is e to the 1 minus 2 times a half, 4 times a half minus 4, okay, which equals minus 2. Minus 2 is smaller than 0, so therefore we can say the point is a minimum. Alright guys, for number 4, it says the following. It says, using the substitution u is equal to root x, find the exact value of this integral. And this integral is between infinity 3, and so 1 over x plus 1 times root x dx. Right. So, they've helped us out. Okay, so if we say let u equal root x, right? That's the same thing as saying x to a half, right? And so we can say that du by dx is going to equal 1 over 2 root x. Okay, which means that du is equal to 1 over 2 root x dx. Perfect. And that actually has helped us out a lot. Okay. Because we're approaching a form that we can then use to plug in, okay, over on this side. So let's take a look at this. If we're plugging things in for x equals 3 and u equals root 3, well, u is equals to root 3. X equals 3, right? And obviously, as x goes towards infinity, okay, we can say that u is also going to go towards infinity. Okay. So, with that in mind, we can then say the following. Well, this is going to equal, okay, we got infinity at the top, 3 at the bottom, and we can just plug in what we've got. All right, dx is going to equal what? Well, 2 du is going to equal 1 over root x dx, okay? And so what we get then is 2 du over u squared plus 1, all right? In other words, du over here, 2 over here, and we could put 1 over there if you wanted to. Let's put 2 here just to keep it all together. Okay. And so from here we can then say, all right, well, this can become 2 arctan u, right? Because according to your trigonometric integral identities, this is true. Okay, between infinity and root 3. Right. And we can say that, okay, whilst you can't plug in infinity, whilst you can't plug in infinity into tan, you can say that the limit as you approach infinity of tan u is going to equal pi over 2. So we can say, then we'll get 2 times pi over 2 minus 2 tan root 3. Right? Now these are going to cancel. So therefore we get pi minus 2 pi over 3, which equals what? Pi over 3. Okay, and that's the final answer. So how do we do that? This is 6 marks, so it's difficult, but we've actually done it quite simply, and not occupying that much real estate here. We let you, well, it told us to do that, let u equal root x, okay? And from there you can work out that 2 du is equal to 1 over root x dx, okay? You realise then that these must be true, and if you plug this in, okay, what you get then is the integral from through to infinity of 2 over u squared plus 1 du. Okay, and then it's just a case of applying trig integrals and using that, you then get pi over 3. And also realization that as we tend towards infinity, okay, tan u, the arc tan of u is going to equal pi over 2. Okay, so we get this in the end. Alright guys, now for number 5, we've got the following question. It says, show that the equation cot 2 theta plus cot theta is equal to 2. And it wants us to be expressed as a quadratic equation in tan theta. It wants us to show that, right? So we know that cot theta okay, is equal to 1 over tan theta, right? We also know that tan 2 theta, sorry, is equal to 2 tan theta over 1 minus tan squared theta, alright? Which means what? Well, what that means is we can therefore say that cot 2 theta is equal to 1 minus tan squared theta over 2 tan theta, right? So what we get then is 1, if we're going to express this in terms of tan, what we can say is 1 minus tan squared theta over 2 tan theta plus 1 over tan theta. That's going to equal 2. Okay, and if we multiply this out now, okay, with the common denominator needed of 2 tan theta, what we get is 1 minus tan squared theta plus 2 is equal to 4 tan theta, which translates then into tan squared theta plus 4 tan theta minus 3 is equal to 0. Okay, that's it. That's what we've done here. Okay, so just a quick recap of that. We've just noted that cot theta is equal to 1 over tan theta, and we noted that tan 2 theta is equal to 2 tan theta over 1 minus tan squared theta. Okay, and the implication follows that cot 2 theta therefore must equal 1 minus tan squared theta over 2 tan theta, because we flip. And then we just plug it in and we get this. Right guys, now for number B, it says solve the equation cot 2 theta plus cot theta equals 2 for the interval of 0 theta pi. Okay, and it says give your answers correct at 3 decimal places. So the way you want to go about doing this, okay, is we've seen from the previous question, okay, that this equation here, okay, can be written like this. And so therefore we can say that we've got tan squared theta plus 4 tan theta minus 3 equals 0. Okay, we can then solve that. We can say tan theta equal to minus 4 plus minus 16 plus 12 over 2, okay? And that's if we apply our quadratic formula now. So we applied a quadratic formula and we've gotten this. So therefore, we get negative 4 plus minus root 28 over 2. Okay? Perfect. Perfect. So, what does that give us then? Well, what that gives us, okay, is a value that says, if we simplify this out, we get tan theta is equal to minus 2 plus root 7, or tan theta is equal to minus 2 minus root 7. Okay, in fact, let me just put that here. Right, and if I draw a quick two tables here, we've got n here, we've got x there. If we've got 0, n equals 0, okay, because tan theta is equal to minus 2 plus root 7. Sorry, forgive me. N and theta, okay. We can say that theta is equal to arctan minus 2 plus root 7 plus n dot pi, okay, because the period's pi, or theta is equal to arctan minus 2 minus root 7 plus n dot pi, okay. So for n equals 0, what's theta going to equal? Well, working that out, we get 0.573. Okay, radians we're working in. If we do 1, we get 3.71 radians. Okay, which is obviously outside our grade here. If we do minus 1, okay, that's going to give us negative 2.368. So that's also going to be out of it. So 3.71 is the only one which is within the, 0.573 is the only one that's within the bounds for n, okay? So n equals 0. We've got n and theta here, okay? And let's say we got the same thing, got 0. Okay. That's going to give us negative 1.35 there. Alright. And if we're already getting negative for 0, then we're definitely getting a negative for n equals smaller than 0. So we can just avoid the negative n altogether. If we do n equals 1, we get 1.78, which is within the bounds. If we do 2, we get 4.9, which is out the bounds. Okay, so therefore, okay, what we get are the following. We get theta is 0.573 rad, or theta is equal to 1.78 rad, okay? And that's going to be your final answer there.